Yesterday, just after noon at 12:37 p.m. local time, a major magnitude 7.3 earthquake unexpectedly struck off of Alaska, causing the ground to rapidly shake back and forth for 29 seconds. While I don't have any footage of the moment shaking struck in the closest populated settlement of Sandpoint 55 miles from the epicenter, preliminary data suggests the level of shaking there was roughly what this simulation shows. After the shaking had ended, it soon became clear that sadly a tsunami had been generated. As a result, tsunami warnings were issued across a 730-mile or 1,175-kilometer long region, and people were told there to flee to higher ground. The minutes then ticked by until, at 1:30 p.m., the first of at least 4 tsunami waves struck Sandpoint. However, and I attribute this primarily to the type of major earthquake which struck, the peak tsunami wave was quite small, maxing out at a height of 30 centimeters or 11.8 inches. It might sound silly to evacuate people from such a small wave, but don't be fooled. A mere 6-inch or 15.2 centimeter high tsunami can easily sweep a person off their feet, as it does not behave like a typical slow-moving wave. Regardless, the tsunami warning was then downgraded to a tsunami advisory due to the expected waves being under 1 meter in height. Across the next several hours, the small-scale tsunami struck additional coastlines in a 270-mile radius of the epicenter, including at King Cove and Unalaska. The tsunami advisory was subsequently cancelled. While preliminary models showed a chance of limited liquefaction and landslides, neither of these hazards appear to have damaged any structures. In fact, so far there have thankfully been no reports of damage or casualties of any kind. The reason I am highlighting this earthquake is that it did not represent what you'd expect in the local geologic setting. Despite its location, this event was not a megathrust earthquake. This is fairly clear-cut when you look at the moment tensor showing an oblique solution which is very strongly strike-slip, specifically a right lateral strike-slip fault that trended towards the north-northwest. So, what caused this earthquake? Simply put, to the southeast of this section of Alaska, the Pacific plate is colliding with and subducting underneath the North American plate. However, this collision is not occurring head-on where both are perfectly moving towards each other. Instead, this is occurring at an oblique angle, meaning that stresses can build up on both the compressing zone and on any primarily horizontal strike-slip faults that exist in the overlying North American plate. Thus, stress builds up due to this uneven motion building until it was released via an earthquake. While in theory, a submarine landslide could have caused the observed small-scale tsunami, I instead interpret that the weak vertical motion of the earthquake created the tsunami. I am tempted to even potentially call yesterday's earthquake an aftershock of a stronger magnitude 7.6 earthquake that struck a mere 35 miles away on October 19th of 2020. As, while it is perfectly true that aftershocks are most likely to occur in a short time span following an earthquake, generally in the following hours to days, they can, at a lesser rate, even occur years, decades, and sometimes even centuries after a main shock. Whether this was a true unique event is uncertain, but I thought I would note this potential peculiarity. Already, more than half a dozen aftershocks have struck, the largest of which so far was a magnitude 5.7. More aftershocks are likely to follow, with this U.S. Geological Survey chart giving a decent estimate on the odds of various particular magnitude earthquakes striking. On average, the largest aftershock following a main shock is 1.2 magnitudes lower than the main shock, which in this case would be a 6.1. As a final note, I would like to thank my new YouTube channel member who has the username The Sky Is Falling for supporting my work.